Hey guys, this lesson is from the end of chapter 3 of calculus. It's not something you'll find in your textbooks, but it is something you will see every single year on several AP questions, especially FRQs, the free response questions. So this lesson is actually going to be taught through questions from old APs. So let's get started. The first thing I want you to be able to draw, we just finished learning about how the first derivative will tell me about increasing, decreasing, max and mins, the extremas, and how the second derivative will tell me about concavity and points of inflection. So every time you see an FRQ, a free response question, that starts talking about any of those things, I want you to feel confident to draw these 6 things as you see here. The plus stands for positive on the graph, meaning above the x-axis. The negative is for below. This stands for increasing, decreasing, concave up, and concave down, okay? So now in between concavity will be points of inflection. In between increasing and decreasing, we will find extremas. And in between being above and below the x-axis, we will find x-intercepts, okay? If you can understand that, this is going to be your goal to solving all of these. So let's talk some details really quick. Extremas are max and mins. And if what these questions usually do is they give you f prime and then they start asking you to use that graph of f prime to interpret information about the function f, okay? So it kind of makes you go backwards. So just some things to review. Extremas, max, and mins, you would be looking for a switch from positive to negative on the first derivative or vice versa, okay? So you're going to be looking for x-intercepts. Now, if they ask you for a maximum on the original, but they're giving you f prime, a maximum is when I switch from increase to decrease. So on the first derivative, I'm going to be specifically looking for a switch from positive to negative. Visually, that should be when the graph goes from above to below the x-axis. A minimum is the reverse of that, when a graph goes from decrease to increase. So on our first derivative graph, we should be looking for a switch from negative to positive, visually being below to above. If I ask you where the original function is increasing, right, increasing, then you're just going to look for where the first derivative is positive or above. If I ask for where the function is decreasing, then on the first derivative graph, you're going to look for where it's negative, where it is below. Okay? Now, let's move on to information about what the second derivative does. So again, they've still only given you the graph of f single prime, and they're asking you about f. So if I want to know a point of inflection, and they're giving you the derivative, we're only going to go one back. Okay, so we're going to be looking for increase and decrease. If they would be giving you the second derivative, then you'd go 2 back on this chart, and I'd be looking for above and below. Okay, just like here when we talked about looking for increase and decreasing, we'd go 1 back and look for above and below. So a point of inflection is a switch in concavity. So on the first derivative, I'm going to look for a switch of increasing and decreasing. And when I switch increase and decrease, visually, I have a maximum or minimum. Okay. Now, if they give you the second derivative and they ask you about the function, now I'm going 2 back. So a point of inflection would be found by a switch in above and below, right? Switching concavity will be found on a second derivative by switching above and below. And then last, concave up and concave down. So if I'm looking for concave up and they give me first derivative, then I go back 1 and I'm looking for when I'm increasing, right? Looking for when I'm increasing on the first derivative. If they give me the second, then I go 2 back and I look for when I'm above on the second derivative. If they want concave down and they give me the first derivative, I go 1 back and I look for where I'm decreasing on the first derivative. If they give me the second, then I go 2 back and I look for where I'm below on the second derivative. Take a moment and write this down, and this is going to start to make more sense as we keep seeing each question. Looking at this first question, if you'd like to print this out so that you can solve it on this paper as well, if you just put in Google AP Cal AB 2009 question 6, it'll come out and you can print this out. You can also see the solution manual on how they gave points that year, okay? So let's start by marking the information that's given. It says derivative of f is defined by these equations. So that means the equations they're giving you are about f prime. And if we look at our graph is also on f prime. Okay? The graph is a continuous function of f prime. They told us one more time in case we didn't catch it. Shown in the figure. And it has x-intercepts at 2 and at 3 ln of 5 over 3. So if you look at the graph, you can clearly see an x-intercept here, meaning that's the one at -2. And you can see one here in between 1 and 2. And they're just letting you know that that one is 3 ln of 5 over 3. Okay? The graph of g from -4 to 0 is a semicircle. And for the original function, there's an ordered pair of 0, 5. Okay, some more important information. Now, looking at A, it says from -4 to 4, find all values of x. That means we're going to put our answers just with the x value, not the y. Which of the graph of f, so notice they're giving me f prime and now they're asking me about f. That's that going backwards that I was explaining to you about. Where on f is there a point of inflection? Very important. And then here, even more important because they always give you a point here. And if you miss it, you'll miss that point. Justify your answer. Okay, so let's draw that chart that I told you. Plus, minus, increase, decrease, concave up, concave down. You're going to draw this every single time. So if they are asking you for a point of inflection, points of inflection happen in a change of concavity. And because they asked us about f, but they gave us f prime, we're going to go back one and look at our switches in increase and decrease. Okay, so again, that right there is our POI. And we're going to look for switches in increase and decrease. Okay, so there are POIs, points of inflection, at x equals, okay, so again, I'm looking for a switch in increase or decrease. So I start here and I go downward. Boom. Here's my first switch in an increase and decrease. Then I start going up, I start increasing. And then right here, which is 0, I have another switch. And then I decrease the rest of the time. So my first switch, again, they asked me for x values. The x value here is -2. And then the next time I switched is here, the x value is 0. Okay? Now the next thing I'm going to write is, those are my points of inflections. Because they did say justify. If I miss the second part, I missed the second point. Because f prime, you have to use the information that's given, f prime, changes, that word changes, every time it says justify, that word should be there, okay? Changes from decrease to increase at x equals -2, and then it changed from increase to decrease at x equals 0. Okay? And those are the 2 points that are given. It's the actual numbers, -2 and 0 is 1 point, and then the explanation is worth your second point. Okay? And again, you are always using the information on the given to answer the f. So you can't just tell me, well, there's a point of inflection because f changes concavity. It's like, no, duh, that's just vocab. But using this graph, I knew that because of the change in decrease to increase. Okay? Now, part B, we're going to skip. Okay? You can answer this once you've learned integrals. So skip until after learning integrals. Okay? Now, for part C, let's look what they're asking. I'm going to move this up a little bit. C says from -4 to 4, so within this graph, Find the, again, values of x at which f, we're doing the same thing again. Now they're asking has an absolute maximum. And then again, it says justify your answer, okay? So I'm going to draw this chart again. Plus, minus, increase, decrease, concave up, and concave down, okay? So if I am asking for a maximum, maximums happen when I change from increase to decrease. I'm going to go back and look over here. So let me just, this isn't going to be part of our answer, but just so you have an idea, we wrote on our previous page that maxes happen when I switch from increase to decrease, which means that on my f prime, I'm going to look for a switch of positive to negative, or above to below. Oop. Okay. So what that means now is I'm going to specifically look for when this graph switches from above to below. Let me see if I grab a highlighter here. Make this a little easier. If I look at my graph, I am above the x-axis here, okay? And then I switch to below the x-axis here. So again, just like in that previous set of notes, we are looking for that x-intercept that I specifically switched from being above to below. So now let's write our answer. Okay. There is an absolute max. Use the same vocabulary that they're using in the question, okay? At x equals, and they told you that that x-intercept is 3 ln of 5 over 3, okay? That's why I like to doodle all over this, because if not, you have to go back and figure out how do I even know what that number is, okay? So again, 1 point is given for the actual numerical location, and the second point is given for the justification. So now I'm going to write because, I'll write BC. This is a graph of f prime. F prime changes from positive to negative at x equals 3 ln of 5 over 3. All right, so again, 1 point is given for that actual x value, and the second point is given for the explanation, the justification, okay? All right, so this question comes from 2012. It is question 3. And for this one, we are actually going to skip part A and B. You would need to learn integration before you can answer these. So we're going to go straight on to letter C, okay? C says, find the coordinates, the x-coordinates, of each point at which the graph of G, so we want the x-coordinates for the graph of G, that has a horizontal tangent. So a horizontal tangent line is a vocab word for an extrema, meaning a max or a min. And for each of these points, then determine whether it's specifically a min, a max, or neither. And then, of course, you can always expect to see that word justify. Okay? So I don't want you to worry about this guy because you haven't learned integration yet, okay? So f is a continuous function from -4 to 3. It consists of 3 line segments and a semicircle. And the graph of f, I'm going to give you this information because you would understand it through here once you learn integration. But this information means that f is G prime. So really, this is the graph of G prime. And again, don't worry about that. You will learn that in chapter 4. I just want to go over the information of max and mins, okay? So if I want to know extremas, I'm going to start off by drawing my usual, okay, plus, minus, increase, decrease, concave up, and concave down. So if they're asking me for extremas Extremas take place when I am switching from increase to decreasing or vice versa. Okay? So that means I'm going to look for changes of positive and negative, meaning changes from above to below. So if I look at my graph, so remember, I'm looking at this for G, so I'm going to go back to G prime. This is a graph of G prime. And I'm going to look for where I switch from above to below and vice versa. Okay? Switching from above to below would be x-intercepts. Okay? So although this one doesn't switch from above to below, it's this scenario of a neither where it hit an x-axis, but it didn't switch. So if you would have been solving this by hand, like with an equation, you would have had that number line. So this is -1. We were above. This is +1. We were below. We hit the x-axis, but we stayed below. Okay? So that interpretation, what we learned earlier this chapter, would have been increase, then decrease, and then still decreasing. Okay? Which is what gives you here, increase to decrease was my max. And since this didn't switch, this would have been my neither. Okay? Now, on the AP test, you do not get credit for this chart, but this chart is really good in helping you kind of map out your thoughts. So, I can say that G, let's use the same vocabulary that the question used. G has a horizontal tangent at x equals -1 and +1. Okay? Because we always have to justify G prime, which I told you was that graph of f, equals 0. You see how it equals 0? Okay, those are my x-intercepts. Now, it says to now say between those two, which is a max, min, or neither. Okay, so there's the first part. There's 1 point already. Now I'm going to be more specific. So these dots are where I'm going to get my points from. I'm going to be more specific to say that at x equals -1, it's a max. So x equals -1 is a maximum because G prime, which in this image was f, changes from above to below, but we're not going to use visual above to below. We're going to change from positive to negative. And then lastly, they did also tell us to mention if there's a neither. So we'll say x equals 1 is neither because G prime, which is f, doesn't change signs. Alrighty, and that's it for part C. Now let's look at part D. D says, from -4 to 3, find all x values for which the graph of G, which we have its derivative here, has a point of inflection. And then, of course, just like justify, it says explain. So let's start off with my positive, negative, increase, decrease, concave up, and concave down. Okay? If they ask for a point of inflection, points of inflection happen when I change concavity, which if I have the graph of its derivative, I need to go one back and find the change in increase and decrease. So I'm really looking for extremas. Okay? So with my highlighter, I'm looking for change of increase and decrease, right? So here I am increasing, And now up here, I change to decreasing. Decreasing, 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 decreasing. And there, I change to increasing. And then one more time, I change to decreasing. So if you look at the question again, it's very clear that it says it wants the x values of where those switches take place, okay? So here's the first time I switch, and that x value, you can see it here, and you can also see it down here, is at -2. Then right here, which is at 0. And then right here, which is at 1, okay? So again, there's a change in increase and decrease, also known as maximum and minimums. So we can answer this question. All right, we can say there is a point of inflection at x equals, we had -2, we have 0, and +1. Because G prime, which is the graph of f, changes, and use this chart, we were looking for changes of increasing and decreasing. Changes from increasing to decreasing, whoops, and vice versa, meaning also from decrease to increase. Okay, so here's where one point goes to your numbers, the other point goes to your explanation, but another way of writing that would be to say because G double prime, right, which would be F single prime. So now we could even talk about all the way back that it changes signs. I'm more of a fan of this first one because I like to follow this chart, but that would also be given credit. All right.